Hey, today we're going to be looking at sum and difference identities in this video. So we have 6 different identities we're going to be looking at. Our first one is our cosine. Cosine of alpha plus beta is equal to cosine of alpha cosine beta minus sine alpha sine beta. So when we have a cosine function, you can see our cosines stick together, our sines stick together. And when you look at our equations, the plus and minus switch to be a minus and a plus. So that's one thing to kind of pay attention to. On sine, the first angle always comes first in the equation, and sine and cosine are getting together this time, and the signs do stay the same. So we have the plus remains a plus, the minus remains a minus, and each time the angles change. With tangent, we have 3 ways we can do this. Our first way is just using the tangent formula, where we have tangent of alpha plus beta would be tangent of alpha plus tangent beta over 1 minus tangent alpha tangent beta. If we switch it up and we have tangent of alpha minus beta, we'd have tangent of alpha minus tangent of beta all over 1 plus tangent of alpha plus tangent beta, or times tangent beta. I'm going to go ahead and say these tangents can be a headache because it's a complex fraction. Tangent being y over x as is over another complex fraction, it can be a little messy simplifying. Do as much as you can whenever you're working on a tangent. Typically, they're going to be simplified to be not fractions anymore. We can always use the identity, though, where tangent of alpha plus beta would be equal to sine over cosine. So we'd have sine of whatever alpha plus beta is and cosine of alpha plus beta. But that would require us working out 2 of these formulas. Sometimes that can be a little bit easier than working out the tangent, though. So we're going to be looking at some of the problems that were in the Springboard book in the multi-angle section, which is section 23. We worked some of these in class, but I'm going to go ahead and rework these. So when I'm given this problem, sine of x plus pi over 3, and I need to verify that it's equal to 1/2 sine of x plus square root of 3 over 2 cosine of x. My first thought is, we just talked about the identity for this. I can expand this. So when I'm doing that, I'm going to start by just kind of writing down my formula just so I have that handy for when I work this. We've got sine of alpha plus beta. I'm going to keep a plus sign because that's what my problem has in it already, is equal to sine of alpha, because alpha came first, and then I have to switch it up because it's sine. So cosine beta, the sign stays the same, plus, now I have sine of beta, cosine of alpha. Now when I do this, I'm just going to plug in straight as is, x being alpha, pi over 3 being beta. So we have sine of x times cosine of pi over 3 plus sine of pi over 3 cosine of x. Now when I work this out, my first thing that I really need to do on this is I need to go ahead and do my evaluation. So I'm going to take my cosine of pi over 3 and my sine of pi over 3 and go ahead and work those out. And just a reminder, pi over 3 gives us the ordered pair 1/2 square root of 3 over 2. So we're just going to be able to plug our x in for cosine and square root of 3 over 2 in for my sine. Now, sine of x, I can't, that's an equation. I cannot simplify that. We have sine of x times 1/2 plus the square root of 3 over 2 times cosine of x. Look at what we were supposed to have at the beginning. 1/2 sine of x, square root of 3 over 2 cosine of x. So I'm just going to reverse my order here and have 1/2 sine of x plus square root of 3 over 2 cosine of x. And since that matches the beginning, we are done with that verifying. Now, the second problem we did today, and where we kind of got to in class, was find the exact value sine of 15 degrees. Now, the thing about working a sine, cosine, or any sum or difference is as long as the 2 angles that you pick out add or subtract to this answer, they're perfectly fine to use. Okay, so for the purpose of this video, I'm just going to do 60 minus 45. But again, you can pick whichever ones that you want. Okay, 45 minus 30 would work. And just about anything else as long as the difference is 15 degrees. So I'm going to start by just kind of thinking, okay, well, I'm going to replace sine of 15 with sine of 60 minus 45 degrees, because 60 minus 45 is equal to 15, so I haven't changed my problem. Now, when I do this, I'm going to start by just kind of remembering back, okay, my sine formula. Sine of alpha minus beta is equal to sine of alpha cosine of beta minus sine of beta cosine of alpha. Now I just need to kind of plug in my values. We can see alpha matches up with 60, beta matches up with 45. So we have sine of 60 degrees, cosine of 45 degrees, minus sine of 45 degrees, cosine of 60 degrees. So now we have 1, 2, 3, 4 evaluates that we have to do. So we have 60 degrees, we have 45 degrees. So I'm just going to kind of remind ourselves of our nice little ordered pairs from the unit circle. We've got square root of 2 over 2, square root of 2 over 2. 60 degrees is 1/2, and square root of 3 over 2. So for my 45s, I'm going to go ahead and replace those. Square root of 2 over 2, square root of 2 over 2. Got my minus sign, I'm just bringing down. And then sine of 60 would be square root of 3 over 2, the y coordinate, and cosine of 60 would be 1/2. Now remember, you can multiply radicals, so square root of 3 times square root of 2 would be the square root of 6 over 2 times 2 is 4. Minus square root of 2 times 1 would be square root of 2 over 2 times 2 is 4. And we have our answer. Okay, so these were the 3 problems that I'd given you today in class to just kind of try before we left, where we have cosine. We're going to start with cosine of 105 degrees. Now there's multiple, like I was saying earlier, there's multiple right ways to do this. The first way that I see to do it would be 60 plus 45. Does that mean if you pick something else that you're wrong? Absolutely not. So I'm going to go ahead and just start by writing down my formula. I know cosine of alpha plus beta. Now my cosines stick together with cosine, so I've got cosine of alpha, cosine beta. Cosine also has my sign switching, so I've got minus sine of alpha, sine of beta. So now I'm just going to, I've got my alpha is 60, beta is 45. So I've got cosine of 60 degrees, cosine times cosine of 45 degrees, minus sine of 60 degrees times sine of 45 degrees. So I'm just going to make a quick note to myself. With 60 degrees, my coordinate is 1/2 square root of 3 over 2. With 45 degrees, it is root 2 over 2, root 2 over 2. So now all we have left to do is plug in 4 times and simplify. So cosine of 60 degrees, we have 1/2 times cosine of 45 degrees, which is square root of 2 over 2. Now minus sine of 60, which is square root of 3 over 2, times sine of 45, which is square root of 2 over 2. So if we work this out, we have 1 times square root of 2 would be square root of 2, 2 times 2 would be 4, minus square root of 3 times square root of 2 would be square root of 6 over 2 times 2, which is 4. Answer. Okay. So now I'm going to look at sine of 7 pi over 12. So when I'm looking at this, my first thoughts are what would add up to, or what would multiply together to get 12, would add up to 7. I would choose pi over 4, pi over 3. because if I get a common denominator, that'd be 3 pi over 12 plus 4 pi over 12, which is 7 pi over 12. Okay, you could have used a difference and as well. Either way is fine with me. As long as the result is 7 pi over 12, it's all cool. So we're going to start off with sine of pi over 4 plus pi over 3. Just because that's how I'm feeling right now. So I know my formula for plus with sine. I've got sine alpha, cosine beta, plus sine of beta, cosine alpha. So when I fill in, I can see pi over 4 is my alpha, pi over 3 is my beta. So we have sine of pi over 4 times cosine of pi over 3 plus, we've got sine pi over 3 times cosine of pi over 4. Okay, so we've been using the pi over 4, pi over 3 a lot today. We know pi over 3, the coordinate is 1/2, square root of 3 over 2. And pi over 4 is the same as it's been, square root of 2 over 2, square root of 2 over 2. We fill into our formula, so we have square root of 2 over 2 times cosine of pi over 3 is 1/2 plus sine of pi over 3, which is square root of 3 over 2, times cosine of pi over 4, which is square root of 2 over 2. So square root of 2 times 1, we got square root of 2, 2 times 2 would be 4, plus the square root of 6 over 4 again. Okay, now some of these we are going to be seeing quite a bit of repetition, and it just kind of goes with the unit circle. The angles that we can make with these are still fairly limited, and so they should be fairly similar to the rest of them. But if you think about it, and this is just kind of going with the unit circle, 7 pi over 12, okay, if I convert that into degrees, that's 105 degrees. So yeah, it should be kind of matching some other things that we've done. Okay, now for the doozy, tangent of 75 degrees. A tangent, I'm going to pick, so any two angles that combine to make 75 would work. Just for the sake of this video, I'm going to go with 45 plus 30. Okay, so 45 plus 30. And so now I'm going to write down my formula. We've got tangent of alpha plus beta is tangent of alpha plus tangent of beta all over 1 minus tangent of alpha tangent of beta. Alright, so with this, I can see alpha is my 45, beta is my 30. I'm going to start by filling in this formula. We have tangent of 45 degrees plus tangent of 30 degrees all over 1 minus the tangent of 45 degrees times the tangent of 30 degrees. So before I can do anything, I need to know what tangent of 45 is, and I need to know what the tangent of 30 degrees is. So 45, so we've got square root of 2 over 2, square root of 2 over 2. When I do my tangent, y over x, or my sine over my cosine, same values, I've got 1. Now when I do 30 degrees, we know the coordinate is square root of 3 over 2 and 1/2. So this is 1 over square root of 3 when I do my y over x. But I'm going to go ahead and rationalize this. So times square root of 3 over square root of 3, which would give me square root of 3 over 3. The reason I'm doing that is because since I'm plugging it into a formula, will be a little bit harder to kind of work with a non-rationalized answer here. So I'm going to take all of that. I'm just going to plug it into my formula. So we have instead of tangent of 45 degrees, we have 1 plus, instead of tangent of 30 degrees, we have square root of 3 over 3 over, we have 1 minus tangent of 45 degrees, which is 1, and then square root of 3 over 3. So that's what we have so far. Now, I'm just going to go ahead and simplify this just a little bit. I'm going to get rid of my parentheses, so 1 plus the square root of 3 over 3 over 1 minus the square root of 3 over 3. Alright, so now with this, I'm going to, first of all, I don't like seeing these fractions. So I'm going to multiply top and bottom by 3 to keep my equation the same. So when I distribute this, what that's going to give me is I have 3 plus the square root of 3 over 3 minus the square root of 3. Now we're fairly close to an answer on this. This is not fully simplified though. So what I need to do to fully simplify this is I need to rationalize. Now this is what we call a complex conjugate. Or not a complex conjugate, but just a conjugate. I don't know why I said complex. Probably because it's been a long day. Okay, so we're going to be kind of playing off the difference of squares of the denominator. So I'm going to multiply top and bottom by 3 plus the square root of 3. Now the bottom multiplies out because that's a difference of squares. So I've got 3 times 3 would be 9 minus the square root of 3 times the square root of 3 would be minus 3. And that's my denominator. Now I actually need to do the top here. So that's going to be 6 as my denominator. So when I multiply the top, 3 times 3 would be 9, plus 3 square roots of 3, plus another 3 square roots of 3, plus the square root of 9. Okay, so sorry, I didn't realize the paper got on top of that, so I'm going to let that sit for a second. Again, I took 3 times 3 for 9, 3 times square root of 3 for 3 root 3. Square root of 3 times 3 is 3 square root of 3. Square root of 3 times square root of 3 is the square root of 9. Again, the bottom was a difference of squares, so I could simply do 3 squared minus the square root of 3 squared. Okay, 9 minus 3 is 6. Now in the numerator, I'm going to do a little bit of a replacement. Square root of 9, I know, is plus 3. So I'm going to combine like terms. 9 plus 3 is 12. 3 square root of 3 plus another 3 square root of 3 would be 6 square roots of 3. Everything divided by 6. Now when I look at my 3 numbers, 12, 6, and 6, all 3 of those could be divided by 6. To simplify my fraction, 12 divided by 6 would be 2, plus the square root of 3. My denominator would be 1, so I do not need to list it. Okay, so yeah, that took me a whole piece of paper to work out one problem. It happens. Do not be afraid to use paper. Okay, that's what it's there for. Okay, so the last couple of problems are going to be kind of dealing with reference or with triangles that we create ourselves. Okay, so we have the following. We have alpha is between 0 degrees and 90 degrees. Beta is going to be between negative 90 and 0. So if we have cosine of alpha is 3 over 5. Since it's between 0 and 90, I know that's first quadrant. Okay, so I'm just going to go ahead and set this up where we've got 5 as my hypotenuse, 3 is my adjacent, and I recognize this is a 3, 4, 5 triangle. Now beta is between negative 90 and 0, which means that it is in quadrant number 4. And I know my opposite is negative 5. My hypotenuse is 13, okay, which means it's a 5, 12, 13 triangle. Okay, so what this means is if I've got an angle between 0 and 90, and I'm adding an angle somewhere between negative 90 and 0, okay, so this is still going to be remaining in either quadrant 1 or quadrant 4, depending on which angle is bigger, alpha or beta. But when I look at my problem here, cosine, I know cosine is both positive in both of these, so I don't really need to worry about any sort of sign on this equation because I know it's going to end up as a positive. So when I'm looking at cosine of alpha plus beta, I'm going to start by just kind of remembering my formula. We've got cosine alpha cosine beta minus sine alpha sine beta. Okay, so I need cosine of alpha, cosine of beta, sine of alpha, sine of beta to plug in. So I already know cosine of alpha is 3/5. I know cosine of beta is going to be 12 over 13. I know sine of alpha is 4/5. And I know sine of beta was given to me at negative 5 over 13. I'm going to take these values, plug them straight into this equation, and then just kind of simplify. So cosine of alpha comes first, 3 over 5, times cosine of beta, which is 12 over 13, minus sine of alpha, which was 4/5, times sine of beta, which was negative 5 over 13. So I'm just going to go ahead and start multiplying. 3 times 12 would be 36. 5 times 13, we've got 65. No, minus. So 4 times negative 5 would be negative 20. 5 times, and so we've got our common denominator still. Now when I minus a negative, that will switch to become a positive. So we've got 36 plus 20. Would be 56 over 65. It is positive like we were expecting. And so we've got cosine of alpha plus beta would be 56 over 65. So just a couple similar type problems. And I know both of these are going to take up some room because I see a tangent. Okay, now this tangent may be a little bit easier because I don't have any square roots. So we've got alpha is in quadrant 1. Beta is in quadrant 2. So I know my angles are somewhere between 0 and 90, and 90 and 180. So if I'm taking sine of alpha, and then I've got my beta is in quadrant 2. Now if I do alpha minus beta, so just kind of think about it. I'm just going to choose an angle that's kind of in the middle of each quadrant. So let's just say this was 45 minus 135. Okay, that'd be a negative answer. And so we could be looking at something depending, it could be maybe quadrant 4. Okay, and that's just kind of, well, if we do 0 minus 90. Okay, we're going to be kind of looking in the 0 to negative 90 kind of area. Okay, so it's really just kind of thinking about it for a second. It could be maybe quadrant 1. We don't know yet. So we're just going to kind of have to mess with it for a second. We've got sine of alpha is 3/5. Okay, so we've got so we know alpha is in quadrant 1. So I'm going to draw my triangle in quadrant 1. So I've got 3/5. I've got a 3, 4, 5 triangle. Now on tangent of beta, it's in quadrant 2, so I'm going to draw my triangle in quadrant 2. Now in quadrant 2, my x is negative, so this is going to have to be negative 15, positive 8. So I've got an 8, 15, 17 Pythagorean triple. So here's the information that we have now. So for sine of alpha minus beta, alpha minus beta. Okay, when I'm looking at this, I'm going to start by using my formula. Alpha minus beta would be, we know that's sine of alpha, cosine beta minus sine beta cosine of alpha. So I need sine, cosine of each one. So in this equation, I have sine of beta would be 8 over 17. Cosine of beta would be negative 8 over 17. Over here on the left triangle, when we have sine of alpha, we're given that's 3/5, and that means cosine of alpha is 4/5. Now we're just going to take these values, we're going to substitute them in one at a time and simplify our equation. So alpha, sine of alpha, we said was 3/5. Cosine of beta was negative 8 over 17 minus sine of beta. So minus 8 over, wait, that should be minus 15 over 17. I'm very sorry, I goofed. Okay, so we got 8 over 17 times sine of alpha, or cosine of alpha. I'm going to stop for a second. Times 4/5. Okay. Now we just need to kind of multiply this out to get our answer. So 3 times negative 15, we have negative 45, and 5 times 17 be 85. Minus 8 times 4, we got 32 over 85. So negative 45 minus 32 would be negative 77 over 85. Okay, so that's how we do that again. So it did end up in quadrant 4, which is, that's just some information that we could use in the future. Okay, so now I want to do tangent of alpha plus beta with the same two triangles. Okay, so I'm going to be keeping this this 3, 4, 5 triangle and this negative 15, 8, 17 triangle. So tangent of alpha plus beta, when we wrote down the formula earlier, that's tangent of alpha plus tangent of beta all over 1 minus tangent of alpha, tangent of beta. So I need tangents this time of these same triangles. So we already knew this one was tangent of beta was given. That's 8, negative 8, 15. Okay, when I come over to the 3, 4, 5 triangle, I know tangent of alpha, my opposite over adjacent would be 3/4. So I'm going to come over here to my problem, and I'm just going to go ahead and do substitutions now. So tangent of alpha is 3/4 plus tangent of beta, negative 8 over 15 over 1 minus tangent of alpha, 3/4, tangent of beta, negative 8 over 15. Okay, now comes the process of just simplifying our fraction. So we have 3 over 4 minus 8 over 15. So I just went ahead adding a negative. That's the same thing as subtracting. And in the denominator we have 1 minus. We've got negative 24 over 60. So now I'm going to get a common denominator in my numerator. So we have 45 over 60 minus 32 over 60 all over, and then I'm going to get a denominator in the common denominator at the bottom, so 60 over 60. Subtract a negative is plus 24 over 60. So now I'm just going to go ahead and combine. We have 45 minus 32 would be 17 over 60 over 84 over 60. Now, just like earlier when I did the trick with multiplying by 3, I'm going to multiply top and bottom here by 60. And so what this will do, what this does is I'm going to have 17 over 84. Wait, it has been way too long of a day. 45 minus 32 is 13. Can't believe you guys let me go that far with the wrong number. Okay, so one that you guys should definitely try, is this one down here. I'm giving you sine of alpha is equal to 1/3, sine of beta is equal to 3/4. I want you to find sine of alpha plus beta and cosine of alpha plus beta. Now, I'm going to go ahead and give you the answers, so you may want to pause now. Okay, so spoiler alert, here are the answers. Only use this if you need to check your work. Negative square root of 7 plus 6 square roots of 2, all divided by 12. Cosine of alpha plus beta would be negative 2 square root of 14 minus 3 over 12. Okay, if you have any questions, make sure you just go ahead and I would suggest write them down, bring them to class next time. That way we have that information to go with. Now, I did say that there was going to be a couple of extra practice problems in the video. We do have 2 that you can check your work on. We have also on page 313, I'm going to be coming around on Tuesday to check for this. 13, A and B. 14, A and B. 316 is 4 and 5A. On page 317, 8, 9, 10, and 14. I would like for you to pick any 2 more from your verifying worksheet because we need all the practice we can get on that. Okay, and if you have any questions about the verifying, you need to let me know. The sooner, the better. Thank you, and have a good weekend, everybody.